start with the first presentation. Jan, the floor is yours.
Thanks a lot, Michael. You have to, I'm about to share my screen. Yes, now I'm able to share my presentation with you. Everybody should be able to see the presentation now. Solar is growing quicker each year. And with this growing fleet of power plants, we have more data available, which can unlock a lot of opportunities, both for the integration of solar plants into the grid, but also for the optimization of these power plants. Now we have important legislative changes coming up, which can unlock these opportunities. But it is up to us now to change them and to adapt them to the needs of the electricity sector to make them fit for solar. In the next 10 to 15 minutes, I hear that you cannot see my screen. Okay, in the next 10 minutes, I'm going to talk about 3 topics. One is the development of the solar market. Then, what are the next steps for data sharing to make use of the data for the solar power plants? And the last topic, cybersecurity. Starting with market development, let's go into it. So 2022 was really the exceptional year for solar worldwide. We saw annual installations grow by 45%, and really going from 165 gigawatt to 239 gigawatt annual growth. The second biggest market is the United States, where they installed 21.9 gigawatt, which is actually 6% below what they've been installing before, mostly due to the ban on imports of solar panels, which was a little bit weakened by strong growth in the residential sector. An important market to point out as well is Brazil, which installed 10.9 gigawatt, doubling the installed capacity from the year before, really with a particularly strong growth in the small scale segment below 5 megawatt. They had a phase out of the net metering scheme, which started a boost a run towards these small scale installations. The third biggest market, something that's worth highlighting as well, is the Spanish market, installing 8.4 gigawatt in 2022. And here, what is particularly interesting about the Spanish case is that most of these power plants were actually outside of subsidies, financed via PPAs, but of course also a strong rooftop solar market in Spain. Now, when we look at the future, at the time from 2023 towards 2027, we expect around 15 to 20% of annual growth. Alone in 2023, we are expecting 341 gigawatt of installations now, despite, I have to really say, despite worse external conditions. So the energy crisis narrative is going down a little bit. With that, the energy prices are also coming down, which is, of course, not that favorable for the business case for rooftops, for solar, and also higher inflation, which makes it difficult to finance power plants. We are expecting, in terms of cumulative installations, we are expecting to hit the 2 terawatt mark by 2025. By 2027, the market share of China, we are expecting it to decrease, going from 41% to only 34% overall market share in 2027. While we expect the Asian Pacific region, that is everything outside of China, to show the largest gain, growing from 18% to 22% market share in 2027. Now, a particular highlight is, of course, the European market, which is really on track on meeting the very strong ambition that has been set by European policymakers of hitting 750 gigawatt DC as part of the Repower EU plans. And really the strong growth is being achieved through strong policy signals by European member states and the European Union. And thanks to those, we expect that the installed capacity to double from 2023 to 2027, from 260 gigawatt to almost 600 gigawatt. Out of these installations today, rooftop solar is still the biggest market. It's taking 62% of the installations. We expect this share to come down a little bit, hitting 59% by 2027. This is to point out that this is really only a small part of the rooftop solar potential. Previous estimations showed that in Europe we can do 560 gigawatt of rooftop solar, but now we are increasingly learning that the potential could be much higher, with up to 1 terawatt of rooftop solar potential across Europe. There was also recently a German study estimating that in Germany alone, Europe's biggest country, we can do 400 gigawatt by the technical potential. So there's really a strong growth to go. Now, going a little bit deeper into the next steps for into data sharing and digitalization, the topic for today's webinar. In terms of opportunities, or what are the next steps where we are going in terms of data sharing? First point is, of course, planning of power plants. There we see two stakeholders which we really have to engage with. One is the permitting authorities, that's municipalities, and the second one is the grid operators. With municipalities, we really have to make sure that we have digital portals where we can communicate really on a live basis and in very short time spans with municipalities to get permits actually quicker. On the grid connection, what we are really wanting to see is that grid operators publish the capacity that they have available on their grids. We already see some grid operators rolling this out. On the slide, you actually see a map of Italy, which points out different grid capacities in the different regions. Yellow showing that there's a lot of grid capacity available. Orange showing it's getting less, and red is really it's turning an issue. And if you are actually able to click on this map to go down to the level of substations, where you can really tell at what substation you still have capacity available. That is a good first step to know where you have available capacity. An important next step will be to communicate also with grid operators through a digital platform to make this procedure quicker. Now, moving from the planning stage more to the design and the operation and maintenance part, there are two key opportunities. One is to merge different data sets to be able to develop and improve your equipment. So on the picture below, you see data from for inverter performance, and you can really tell when the inverter has to be replaced. And you can when you start comparing this or merging these data sets with different data sources, you can really make even better use of those, which at the moment still poses a barrier. Second point here is to start comparing power plants with each other. So you start to look at power plant A, B, and C, and then you can compare the different performances, which allows you to get some insights on what configurations work more and what work less. The third big next step is the integration of PV assets into the electricity grid. And here we have to make sure that we have the right markets available so that there is a strong incentive to actually connect the different devices to each other. On the right, you see two graphs. One is a survey by installers indicating that around 50% of installers don't only install PV anymore. They also install heat pumps or electric vehicles or home energy management systems, really showcasing that this is not isolated technologies, but they're coming together. Similarly, we see increasingly smart meter rollout in Europe. So we have all this data available, which now, which of course induces a lot of complexity, which we have to reduce. And that is to optimize self-consumption. So optimize, if you have a rooftop solar system, you optimize what's actually staying behind the meter and limit what you export into the electricity grid, which requires, of course, a lot of coordination between the devices. Second important market that we have to develop is grid services. So both local flexibility markets, but also balancing services for transmission grids. Here we also have a lot of opportunities to develop additional value for PV power plants. Third big element here to unlock to better use data for solar integration is to remove barriers for market models. So I'm thinking here now about time of use tariffs, energy sharing, but also time-dependent injection compensation when you inject into the electricity grid. These are all really incentives that allow the product developers that force grid operators to make better use of the data by integrating the assets into to the time-dependent tariffs. Now, we have one important law that is coming up here, and that is the EU Data Act. The EU Data Act is now already in national transposition. It was agreed upon in June, and this law will really facilitate data sharing. Why is that? Because it requires the data holder to make data available upon the request of the user. So if you can imagine, you are a project developer, you have an inverter, and then you can request from the inverter company to give you the data, or to forward the data to a third party, which is, for example, an O&M platform, so they can use the data from the inverter. It's a big step. For sharing data with users, there's no compensation involved, but for sharing data with third parties, there has to be a compensation. The data must be shared at the same quality as it is available to the data holder. It must be shared in a commonly used machine-readable format, including all the context information that is necessary to interpret the data. It has to be shared where feasible, continuously and in real time. So really, we see a comprehensive approach to facilitate data sharing. There are some exemptions, of course, based on trade secrets, allowing companies to develop and to develop their products and to monetize their products and maintain that advantage based on intellectual property. There are exemptions for cybersecurity reasons, physical safety, but also there are exemptions in place if the data recipient has insufficient security controls, because of course, if the manufacturer is required to share the data, you cannot leak the data at the data recipient. This is a big step towards making data available. Now, how this will be implemented is still to be seen. The text is quite broad. It lacks details. There are no precedents for this text, so in the end, it will really depend on national implementation on how this will turn out. There is a risk that this will be fragmented across the European market, and as there are no precedents, there could be the EU Court of Justice, which in the end speaks or changes the implementation across European member states. Now, for us as the solar sector, we now really have to define what this means for electricity undertakings. We have to define the exemptions for this data sharing. We have to define guidelines for remuneration for data sharing. And of course, we also have to define the modalities of how we want this data to be shared. So the roles, the rights, the responsibilities, any standards that are being used, communication protocols. So really the technical details. Now it is for us to show the European Commission how we can transpose this Data Act for the electricity sector. Coming to the last point of this presentation, cybersecurity. Now, with all this energy data being available, we are, of course, increasingly exposed to cyber risks as well. That is risks of losing data, risk of data being manipulated, which can contain privacy-relevant data, and which in the end can turn to litigation claims for the manufacturers. That is the first risk. There's also a risk of temporary failures of power plants. We consider this to be less of an issue in general, because inverter manufacturers can usually reboot the device, which can then bring the power back on. As well as if you lose a solar plant for 1 hour, the damage is relatively limited. The bigger risks that we see is if in the future terrorists can actually target blackouts by manipulating the PV data. And this is especially relevant when equipment is targeted at the fleet level, and especially if vulnerabilities can actually not be removed quickly enough. You can either cause the grid to collapse, which takes time to start the grid again, but you can also cause physical damage to the devices, which then in the end will take even longer to reboot. Vulnerabilities, the most common vulnerabilities here are remote control capabilities, insecure system configuration, which are really at the forefront. We have a lot of attack surfaces, starting only from outdated software, weak authentication mechanisms, configuration errors. The list is quite long here. And what we see is that the high quality manufacturers take a lot of measures to mitigate these risks, but with low cost products, we are more concerned when they have actually insufficient cybersecurity protection. Now, also here, the EU is taking some steps. There are two legislative proposals out there. There's the NIS2 directive and the Cyber Resilience Act, where the NIS2 creates horizontal requirements for network and information systems, especially for entities in critical and important sectors, which have to take cybersecurity measures and which can be controlled by state authorities. So this is for network and information systems. Now, the Cyber Resilience Act really focuses on the product level. And on the graph on the right, you see what obligations are becoming relevant for manufacturers. So it really starts with the design phase, where the manufacturers have to do an assessment of cybersecurity risks. Then in the design phase, they'll have to consider any vulnerability that they have discovered in the assessment, consider this in their development process. They have to plan vulnerability handling procedures, and there are really far-ranging reporting obligations which require a manufacturer that has been subject to a cyber attack to report this to government authorities. All these procedures taken by manufacturers are being controlled by state authorities for products that are less risky to harm public infrastructure. A manufacturer can fulfill the requirement by adopting a certain standard or by complying with a certain standard. But for devices which are actually with critical impact on the infrastructure, there is a third-party assessment necessary, where state authorities really control how manufacturers have implemented these measures. And again, this also is a broad text. So now we as the electricity sector, as the solar industry, have to now go into detail to make sure to show what does this actually mean for the different products in the solar value chain, and how we can implement this and make this work in practice. These are the next steps for us. This has been it for my presentation. The last thing that I want to share with you is invite you to join us in SolarPower Europe's digitalization workstream. We have been developing all these ideas in this workstream. Please join this discussion. Thank you very much.
Thanks, Jan. Great overview. So we have the questions or the Q&A afterwards in the panel. If you have any questions directly to Jan in the meantime, please write it into the chat, and Jan can answer those questions then.